A very good afternoon to all the participants present over here. I request Professor Y.A. Kulkarni sir to give the welcome speech.
Thank you, madam.
Sir, please.
Hi, everyone. Please and known to all the wonderful minds present over here. Myself, Mr. Y.A. Kulkarni, Faculty, Department of Science and Humanities. Let me take this opportunity to welcome you all to this event with a wonderful quote. The success is not a final, failure is not a fatal. It is the courage to continue that counts. There are two kinds of people in the society who tell you that cannot make any difference in this world. Those who are afraid to try new and those who are afraid to your success. I believe this is one of the best quote to live by because it reminds me to think about without limits and never doubt on my wildest thoughts. Dear students, I feel very much fortunate to welcome respected speaker of today's event, Dr. Lokesha, Professor of Mathematics, Krishna Devaraya University, Bellary. Sir, welcome you. And I welcome all the participants who are very much enthusiastic to witness this event. Welcome you all. And also, I welcome the host of this event and all the technical hands behind this webinar. Welcome you all. Thank you.
Thank you, sir. Now I request Dr. Pratima Naktran madam to give a brief introduction of our today's speaker, Dr. V. Lokesha.
Good afternoon. Thank you all for attending today's webinar. Myself, Dr. P.S. Naktran, Assistant Professor, Department of Science and Humanities. It gives me an immense pleasure to introduce and welcome our resource person, Dr. V. Lokesh. He is currently working as a professor in mathematics in Vijayanagara Sri Krishnadevaraya University, Bellary. He completed his PhD in Mysore and DSc in Berhampur. His field of expertise are analysis and discrete mathematics and graph theory. He guided 28 MPhil students, 17 PhD students, co-guided 3 students, and 7 students are pursuing PhD under his guidance currently. He has published 192 research articles in national and international reputed research journals. I feel delighted to tell that Sir's Google Scholar citation is 1097, H index is 17, and I index is 27. Sir has, to his credit, 52 American Mathematical Reviews, USA, and 156 Central Blatt Reviews, Germany. Sir has visited Canada, Iran, Turkey, France, and South Korea for research activities. He is Fellow Associate of Karnataka State Science and Technology in 2021 and Fellow of Society Science from 2011. Sir has completed project in 2017-18 receiving a grant worth rupees 9,60,000. He was being awarded Karnataka State Award for Research Publication with cash prize 25,000 in the year 2016-17. He co-authored 6 books published by Dr. Padmanabhan. The position he held are Registrar Evaluation in Charge, Special Officer for Evaluation Section, Special Officer for Academic Section, and Deputy Registrar for Administration of VSK University. He was a member of Academic Council, Finance Committee, and Library Committee. He was chairman of DOS in Mathematics, BOS chairman in Mathematics, and co-coordinator for DOS in Computer Science. He worked as a nodal officer of Ballari Center KSET examination, nodal officer for CBCS syllabus, and director in MCA Institute in Achara Institutes. He was also a scientific committee member for many international conferences organized in India and foreign countries. He is member of BOE, BOS, BOA of many Indian universities institutions. He has worked as a life member of 20 academic bodies. He has organized 6 conferences, workshops, and lecture series. He has conducted 24 live telecasted online lectures in VTU EduSat program. With this introduction, I humbly request Dr. V. Lokesh sir to deliver his valuable thoughts on applications of mathematics in engineering. Sir, please.
First of all, I would like to thank Asha madam. You gave a more introduction about me. I'm a very small person. I'm not the cooperation of the mathematicians. I done little in the field of mathematics. First of all, I would like to thank the organizers of the institute giving a opportunity to share my thoughts in this webinar. Applications of mathematics, because I served an engineering institution more than 15 years in my service, and also we wrote some of the books related to engineering. After a long time, I am discussing with the engineering students as well as our friends, teachers. Okay. First, and also a special thanks to Desai, is my friend. He invited me to give a seminar. Many times he asked, because of my schedule, I taken a lot of time to do this one. First, I will start today's lecture related to applications of engineering mathematics. Let us start, man. Is it visible?
Yes, sir, it is visible, sir.
Okay. Today's, first of all, I welcome all my youngest students and also teachers of Engineering Institute and other institutions. My title of talk is Applications of Mathematics in Engineering. But I will start with one of the important relationship. In my talk, I will start with the engineers and as well as mathematician, how they are interlinked with the people, and also some of the famous mathematicians and engineers. Some of the mathematician as an engineer as a mathematician, that is the first concept. And what is some of the differences between mathematician and engineering works, and where the application of mathematics are arise, that is another opinion. Then I will focus more on the one area I will choose, because the time limit I taken as calculus is one of the area I will concentrating in my talk. That is famous 5 mathematicians as well as engineers. Everyone knows the name of Isaac Newton. In the 16th century decade, he considered to be the greatest scientist of all the time. There are many subjects Newton didn't have a huge impact in. He was one of the inventors of calculus, built the first reflecting telescope, and established the field of classical mechanics with his works. He was the first to decompose white light into the component of colors and gave a three law of motion, now known as Newton laws. We as everyone is studied in our school time itself. Objects at rest tend to stay at rest. Objects in motion tends to tends to stay in motion unless acted upon by an external force. This is the impact of the Isaac Newton in 16th and 17th century. After that, Carl Gauss in the 17th century could easily be called as the greatest mathematician ever. He published Arithmetical Inequalities, a foundational textbook that laid out the tenets of number theory. You know that the study of whole numbers, without number theory, you couldn't kiss a computer's goodbye. Computer operate on the most basic level using just two digits. One is 0 and another one is 1. Many of the achievements that we have made in using computer to solve problems using number theory. Gauss was a prolific, and his work on number theory was just a small part of his contribution to math. We can find he influenced throughout algebra, statistics, geometry, optics, astronomy, and many other subjects that underline our modern world. And in the 19th century, John Newman, 1903 to 1957, he is received his PhD degree in the age of 22 years, while also earning a degree of chemical engineering to appear his father, who has keen on his son having a good marketable skill. In 1930, it is a remarkable achievement by the John von Neumann. He went to Princeton University with Albert Einstein at the Institute of Advanced Study. Before his death in 1957, von Neumann made important discoveries in set theory, geometry, and quantum mechanics, game theory, statistics, computer science, and was a vital member of the Manhattan Project. Everyone knows that that is a code name. First atomic bombs in the nuclear technology done by US. That is one of the important contribution by John Newman. Next important man, that is Alan Turing. Alan Turing is a British mathematician who has been called the father of computer science. During the World War II, Turing bent his brain to the problem of breaking Nazi crypto code and was one of the finally unraveled messages protected by infamous enzyme machine. Being able to break Nazi codes gave Alice an enormous advantage and was later credited by some historians as one of the main reasons Allies won the war. Turing's contribution to computer science can be summed up by the fact that his name adorns the field of top award. Everyone knows that Nobel Prize is the one of the prize, biggest money and fame is in the field of chemistry, botany, and many other fields. But Turing Award is the award is in the name of this person in computer science, similar to field medal to the mathematician. Because you know that mathematicians don't have a Nobel Prize, but they have a field medal. One more in the 19th to 20th century, that is Benoit Mandelbrot, landed on his list of thanks to his discovery. You know that he is the man behind the fractal geometry. What is fractals? Often fantastical and complex shapes built on a simple and self-replicable formulas are fundamental to the computer science as well as graphics and animation. Without fractal, it's safe to say that we would be a decade behind we are now in the field of computer generated images. Fractal formulas are also used to design cell phone antennas and computer chips, which takes advantages of the fractal naturally ability to minimizing the wasted pieces. That's why I chosen these are the five mathematicians as well as engineers contributed. That's why I started my talk with these famous five mathematics introduction. Now, why do we need mathematics? You know, it is required everywhere, anywhere, every time, like in engineering, medicine, banking, finance sector, business, construction, and the most important use is definitely for personal day-to-day work. You know, mathematics is a tool we can learn when the baby is born itself. Mathematics is inbuilt character, but we cannot express. That is the beauty of mathematics. That's why we say that mathematics is a queen of science. What are the applications of mathematics in engineering? Linear algebra, vector analysis, calculus, statistics, differential equation, numerical analysis are taught as they're important to the understand many engineering subjects. Maybe everyone in the first and second year of the course of mathematics in engineering, everyone learned in the one or the other stage. They are learned. These are the fundamental things studied their engineering course. And some of the advanced topics, some of the mechanical engineering and other fields, they are studied fluid mechanics, computer science, there are discrete algorithmic approach and discrete mathematical structures, graph theory and graphics are studied in computer science, in heat transform and biotechnology. Nowadays, DNA structure, everything can be done using some of the mathematical concept. In medical analysis, nowadays, many coding theory and especially linear algebra applications are appearing in medical sciences. In electrical circuits, mechanics, and data analytics, these are some of the important areas, applications of mathematics in engineering. Now, one of the important area, now another 10 to 20 years, that data science is coming into the picture. In this data science, if you have a good mathematical and as well as engineering background, definitely you have a bright future in your area. Now I will use the olden days, the use in engineering, use it in physics extensively. If you make something, that we can say that it is physics. If you make a graphics, then we can say that it is structurally. Use it in civil engineering, because in the era of 19th, 18th century, civil engineering means it is a practical applicability. That's why these are the things used in engineering. It's used in every field of engineering, that is construction, defense, aeronautics, medical science, bioinformatics, nanoscience, research work, and many more. The mathematics will be inbuilt. Now I will how the differentiate between a mathematician and engineers. Usually, mathematicians specialize in applied mathematics. Many are focused extensively on researching and proving the mathematical concepts. But engineers use their knowledge to create plans for the product or structure. Using that concept, the engineer can build a product or a structure and must ensure their creation compile it with some of the regulations so that they will function as intended and to be safe. All the regulation formality, then they can model the thing that is known as engineer's job. Usually, if a blended with mathematics and engineering capability, he will be the one of the a strong person, good scientist. He can produce many things in the life. Now I will focus on the mainstream. These are some of the introductory part. Whatever I given, that is the motivation for the studying mathematics and engineering core. In this talk, I already told I will focus on mainly on calculus. In that calculus, I will how it is evolved, then how it is evolved. Usually calculus is originally called as infinitesimal calculus. The calculus of infinitesimals is the mathematical study of continuous change. In the same way, you already know that geometry is the study of shape and algebra is the study of generalization of arithmetic operation. Similar way, calculus have two branches. One is differential calculus, another one is integral calculus. Then after the calculus things, I will discuss with the differential equation and how the differential equation is the formation of the differential equation. Then in that differential equation, we can make a model, then that is a formation. After that, we can solve the differential equation using different techniques. Then we get a solution for the differential equation. Model can be, that is the first type of modeling done in differential equations. That things we will discuss. Then finally, I will give some of the examples or illustration related to this differential equation. I will conclude with my talk in the illustration. Let us start. What is calculus? You know that already I defined it is infinitesimal calculus. The students aware that in the calculus we are studying differential calculus and integral calculus are the two important areas, and the former concerns instantaneous rate of changes, the slope of the curves, while the integral calculus concerns the accumulation of quantities and area under the between the curves. These two branches are related to each other by fundamental theorem of calculus, and they make use of the fundamental notion of convergence of infinite sequences or and infinite series to well-defined limit. This is the fundamental structure. You know that what you started with in calculus. Maybe all of you studied calculus in your few classes. You know that in a life structure, I will make one example always. Whenever we take it as a calculus is in our lifestyle, first what you studied in your calculus. First we always make two persons. Generally we take y is equal to f of x is a function. One of them, x, is an independent variable and y is the dependent variable. First, we can make a function. We made a relationship between independent and the dependent variable. After that, here we make a function that is y is equal to f of x. You know that you all dependent to your father. That is the function. There is a relationship. There is a different type of relationship can be done. Here, in that, after that, what you studied, the function is ready. Then we make the region where we can play. There are two players are there. One is independent, another one is dependent. Then what we make, they can do something where they can play. They can play in a region or a domain. First, we can make it. Usually, we can start with a interval, any interval, closed interval, or first we can define in a closed interval or in a open interval. After that, what they play in that, we can make some rules. We can fix a limit. What is the limit? Limit of a function. First we define a limit. In that limit, we cannot go outside the limit. You cannot get the value. That is a fundamental thing. After the limit, what you studied of the function, that is the continuity. The people, what they are independent and dependent, they must be in the continuous in that region, or sometimes we say that he must be bounded to the interval or the region or the domain. That may be, they must be continuous in that curve y is equal to f of x. After that, we make some changes. First, is it a limit is appearing? Then we will check, is it a continuity is there? Then only the differentiability apply. What is differentiability? Means rate of change. What happens if the movement is done? That is known as the limit, continuity, and differentiability. You know that suppose I will give one simple example for this. You have a fixed time in a semester scheme. We have a 4 months time. You are entered to the engineering course. Suppose we say that you are in the first semester course. Then you have a fixed limit 4 months time. You have some subjects, that is the period, and you are all dependent to the teacher, what they are teaching. And after that, you are the study is the area of the thing. If you are in the 0th position, you're going to a 100th position, means the marks is make into 0 to 100 is the limit. Area is fixed. That is the area in that you are studied in this 4 month continuously. That is a limit is already done. Then continuity, you are continuously studying in this period, 4 month periods, you get good marks. The slope is always, rate of change is fixed. That is same. That is the application, real life application. We can apply in some other direction also. Now I will start with the definitions. What is limit? A real valued function y is equal to f of x is said to be tend to a limit delta as x approaches to x naught. If for every epsilon greater than 0, we can find a delta positive such. This is known as epsilon delta definition. Generally in mathematics, we will say in suppose we say that f of x is as a limit x tending to a, f of x exists and f of a is defined. Then we say that these two are equal. Then we say that left hand, suppose we can take a boundary limit of a comma b. It is the boundary closed interval, means left hand limit, right hand limit, and the functional value. All the three are equal. Then we say that it is a limit will be there. Limit happened to there. Then after that we will discuss about this is symbolically we write as limit of extending to x naught f of x is equal to delta. Next is continuity. You know that a function f of x is said to be continuous, and we say that it is well defined. Function f of x is continuous at particular at a point x is equal to a, f of a is defined, f of limit of extending to a, f of x limit exists, maybe left hand or right hand both are exist, and the functional value all the three are equal, then we say that the function is continuous. Next stage is, you know that f of x is said to be continuous if it does not have any breaks in that interval or the region. Now we will move on to a differentiability. You know that f of x is said to be differentiable. You may be aware of that. What is the first principle? How to make a differentiability concept? You studied in your second PU classes. You started with y is equal to f of x. If you change x changes to x plus delta x, then automatically the dependent variable y is also changing to y plus delta y. Then you can move on to the rate f of x plus delta x minus f of x divided by delta x limit delta x tends to 0. That is the first principle thing what you learned in your PU class. That is the first principle is the definition of differentiability. This is the same thing I mentioned here. In the different ways we can approach left hand and right hand derivative, both are equal. Then we say that if it is in the interval stage, we say that left hand derivative is equal to right hand derivative. Then we say that it is a differentiable. After that, you learned many properties related to differentiability, linearity, constant, and some of the function, exponential function, differentiability. What happens? It is decrement. That is, you studied the many formulas related to the formalization, means algebra of calculus, differential calculus also. You studied sum of two differentiable function is again differentiable, product of two differentiable function is again different. These are the things you learned. Means the rate of change happened. That is the main of rate of change is known as differentiability. And some of the applications are also you studied in your PU class, that is related to velocity. If you differentiate once, we say that it is velocity, and if you differentiate twice, we say that it is acceleration. That are the some of the applications related to differentiability. A function f of x is said to be differentiable. We can draw a tangent at each point. Every point in that interval must be the same. Now I will not move on to more on concentrated on the integration, because integration is a reverse process of differentiation. We say that summation is known as the summation is the simple form of an integration. You are learned first differentiation, then you studied integration. Actually, the integration comes first into the picture, then only for formality and for study purpose, we studied differentiation first, differential calculus. And the integration is known that you have studied area under the curve, integral between A to B, these things. You studied one independent variable with respect to another independent variable. Here I will mainly focusing in my talk, because time limit, I concentrated only ordinary differentiation, not for the partial differentiation. Some of you are aware of the partial derivative also. What is the main thing of the partial derivative? What is partial derivative? You know that suppose z is equal to function of x comma y. We say that x and y are two independent variables. Dependent to one of them, then we say that that is, suppose more than one independent variable is there, then we use partial derivative. Suppose I will give one simple example for this. If you take a iron rod, if you heat that one, the iron rod, there is simultaneous change happen. What are the things happen? Maybe color change, sometime heat with temperature will be changed, and the dimension may be change. There are simultaneous change happening if you are applying one thing. If you heating the thing, the many changes happen. We cannot concentrate one thing that time the rate change. Wherever the rate is change is happening, then we use partial derivative. Leaving other things as a constant, we can differentiate the function. That is known as partial differentiation. Many applications you have studied in your higher classes, majorly in the mean value theorems, many things, Taylor's theorem and other things you learned in the partial derivative, as well as more than one variable, several variable you are learned in your higher standards. Here, now I will focus some application, easily observing if you're going day to day things. Many aspects of civil engineering require a calculus. Firstly, derivation of the basic fluid mechanics equation requires a calculus. Wherever differentiation or integration happen, that is fluid mechanics, fundamental thing is calculus. For example, all hydraulic analysis programs which aid in the designing of a storm of a drain and open channel system. This is the open channel system and use a calculus numerical methods to obtain the result. How much we can ground room to the thing. That's why we need the numerical approximation methods you are learning in your third and fourth semester course. In hydrology, volume is calculated as the area under the curve of a plot of flow versus time and is accomplished using calculus. These are the things real life application we can see in the civil engineering. Many examples of the use of calculus are found in mechanical engineering, such as computing the surface area of objects to determine friction forces, designing a pump according to a flow rate and head, and calculating the power provided by a battery system. I already mentioned Newton's law of cooling is governing differential equations in HVAC design that require integration to solve. In structural engineering, calculus is used to determine the forces in complex configuration of structural elements. Structural analysis required to seismic design requires a calculus. In a soil structure context, calculations of bearing capacity, shear strength of soil are done using calculus, as it is the determination of lateral earth pressure, slope stability in complex situation also using the calculus. And you know that calculus means it is a rate of change. Nowadays, agricultural research, agricultural engineering are mainly utilize the calculus. The statistical part of the calculus is applicable in agricultural sciences. And also nowadays, you know that in the medical sciences, medical engineering, there is a graph structural calculus are utilized for the purpose of studying the medicine and other things. Because if you make a practical application, it takes more time. Instead of that, the mathematical calculation tells the how much we can do the calculation purpose, how much we can apply some of the things. Now, we move on to a major how the formation of the differential equation. This is the thing, the general form. What is differential equation first? An equation, first a differential equation is there. You know that equation means there is an equality symbol will be there. Then we say that if anything will be there in In between there we use a symbol equation, means equality symbol, then only we say that equation. Some of the students and others are seeing that some of them are thinking that greater than lesser symbol, it is not an equation. You must remember it is an inequality. If equality will be there, then only we say that it is equation. Here differential and equation are there, two words. You know that any equation containing differential coefficients and independent as well as dependent variable, then we say that that equation is known as differential equation. Means differential coefficient means, suppose we say that y is equal to f of x, dy by dx is known as the differential coefficient, sometimes dx by dt, dy by dt, depending on the independent and dependent variable. First, what is the formulation of a differential equation? How we can make a formulation? Every one simple thing, you know that circle. Suppose we say that the pi, you know that is a circle shape. The pi can be enlarged and decreased. That is, you know that what we say that suppose that is a circle shape. It is a circle shape that generally we say take in the two dimension, that is x square plus y square, because we make a circle in a Cartesian coordinate system. We fix means x and y are the coordinates, then definitely we say that in a two-dimensional, the general equation of a circle is x square plus y square is equal to r square. You know that x is the x-axis, y is the y-axis, and r is the radius. Here r is the parameter. Depending on the parameter circle we can draw. Radius, depending on the radius, it will change. There is a rate of change is happening in that circle. There is some error or something happened in the circle. First, we draw a circle equation, x square plus y square is equal to a square. Now, the formation of the differential equation comes here. What is differential equation? You can differentiate the given things, eliminate the parameter, that is 2x plus 2y into dy by dx. Here a is a constant, that becomes 0. Then the equation becomes dy by dx is equal to, what is that? X square is 2x, then you get minus x by y form. That is known as dy by dx is equal to, you get something. That is a differential equation. Here parameter is removed. If you integrate that system, you get dy by 2y into dy by dx, then you get log x and dy. Again, you get a come back to the original position using the different methods of the differential equation. You can solve the differential equation. Maybe you're all aware of the some of the important solution, how to solve the differential equation, ordinary differential equation, that is separation variable, exact differential equation. If it is a linear models will be there, we can use Bernoulli equation and linear equation, linear form, and many other things we can apply and solve the, depending on the equation, we can solve the differential equation. We get a solution for the differential equation. You can make a model for the differential equation, then formulate that, you get a solution. That is the thing here he mentioned. For any given differential equation, the solution is of the form f of x comma y c1 c2 etc. Because y is equal to f of x is the thing we are taken, where x and y are the variable, c1 c2 cn are all the arbitrary constant. Sometimes we say that it is a parameters. I already given an example. If you differentiate the given function with respect to particular independent variable present in that equation, keep on differentiating such a way that if the equation, depending on the constraint, we can make a n plus 1 equation. If you solve that equation, you get a, eliminating the constant, we get a differential equation. This is known as the formation of differential equation. Now I will give some differential equations are absolutely fundamental to the modern science and engineering. Almost all known laws of physics, chemistry are actually differential equation, because wherever the change occur, it is calculus only. That is differentiation. That's why. Where is a movement is going on, definitely we say that it is a differentiation is there, then equation form. And the differential equation models are used extensively in biology to study biochemical reactions, population dynamics, organism growth, and the spread of the diseases. You are aware of that. Yeah, everyone in the TV channels and papers, you are heard that now coronavirus disease is growing exponentially. You know that exponential. What is equation? Y is equal to e power x. That is exponential growth. Exponential growth. It is because 2 power 2, 2 power 4, 2 power 6. That is the beauty of mathematics to an equation, differential equation. Wherever you observe properly, you get a applications of mathematics. The most common use of differential equations in science is to model dynamical system, that is system that change in time according to some fixed rule. For such a system, I taken one of the example, the independent variable t here for time instead of x, meaning that the equation are written like this: dy by dx is equal to t cube into y square. Then in addition, sometimes the letter y is used replacing depending on the variable under the consideration. Suppose t, you need a time, we can use t. We can use mass, you can use m. P means population. Sometimes in the commerce people, they use sigma x, means that is the change happening in the variation. That also studied by commerce people and many more. How the natural growth equation. Now I will come across some illustrated examples. The most common differential equation in the science is the following. The natural growth equation is the differential equation. You can see here dy by dx is equal to ky. I told here k is a constant or a parameter. Here the differential equation is there. How to, this is the natural growth equation. How to solve this? You already know the method of the separation of variable. Here we can make rearranging dy by y and dx to this side. Then you get dy by dx is equal to k into dx. Then if you this become dy by dx, dy by y means it is log y. Log y is equal to k into x plus some constant. Here 1 by, this is log y, then log y is equal to e power y. Then we can make in terms of equation, it is a solution is in the form of y is equal to y naught into e power kt, because here you get log y, you can transfer there e power k into t. Then there is a constant, we put in some initial values, y is equal to y naught is the initial value of y. This is the growth equation. Here we skip the sum of the simple calculation. The first order, first degree equation can be solved by separation variable. We get the solution. If you are assigning some initial values, you get a particular values for the natural growth equation. Depending on that constant, here the growth will be changed. The constant k is called the rate of constant or a growth constant. and as a unit of inverse time, that is number per second. The sign of k governs the behavior of the solution. You can see here one of the, if depending on the k value, how the curve, the growth is changed here, the equation, the variable y increases exponentially over a time. This is called as exponential growth. K is greater than 0, y is equal to e power kt. Here we say that t and r, sometimes depending on t is a variable, that's why here t and y. This is the one. And if k is less than 0, the variable y decreases exponentially over time. It is change. This is called exponential decay. This is known as exponential here growth. This is the decay. Now we can take one more example. Consider a colony of bacteria in resource-rich environment. Here, resource-rich means, for example, that there is a plenty of food as well as space for the colony to grow. In such an environment, maybe you heard about the China's, that is the population P of the colony will grow as individual bacteria reproduce via binary fission. That you applied this coronavirus, how the spread, assuming that no bacteria died. The rate at which such a population grows will proportional to the number of bacteria. For example, the population might increase at the rate of 5% per minute, regardless of its size. Intuitively, this is because of the rate at which individual bacteria cell divide does not depend on the number of cells. That is the thing. That can be expressed by the differential equation with respect to population, with respect to time. dp by dt is equal to k to p. This is again a first order, first degree equation. We can solve by the method of separation variable. You get the thing where k is a constant proportionality, which can be interpreted as a rate at which bacteria reproduce. Suppose I will take the particular time, k is equal to 3 per hour. It means that each individual bacteria cell has an average of 3 offspring per hour, not counting grandchildren. It follows that the population of the bacteria will grow exponentially with respect to time. P is equal to P naught into e power kt. That's why we use the coronavirus, how it is spreading, that can be controlled. Don't touch with each other. These are the things happen. This is the fundamental. Mathematically, we can calculate how the growth can be. We can modify the thing. That's why we made some, our governments taken a decision related to lockdown and other issues. Cannot spread the bacteria so fast. Here, P naught is the population at time. This is the exponential growth of bacteria population. This is the one of the examples. Now I will take one more example, that is, consider a sample of certain radioactive isotope. The atoms such an isotope are unstable with a certain proportion decay in each second. Is decaying in the radioactive activity. In particular, the mass m of a sample will decrease as atoms are lost. With the rate of decreased population to the number of atoms, again the formation of the differential equation. Here, math with respect to time, it is reduced or lost. That's why we mention minus. dm by dt is equal to minus r times m. Here, r is the change here, where r is a constant of proportionality. It follows that the mass of a sample will decay exponentially with respect to time. Here I mainly concentrating only one example. There are lot of examples will be there. I focus only one type of equation here. That is m is equal to m naught into e power minus rt, where m naught is the mass of the sample at the time t is equal to 0. Then this is the exponential decay of an radioactive isotope. In RC circuit, the voltage produced by a capacitor is applied directly across a resistor. Here we can setting a two formulas. For V is equal to the others gives R is equal to Q by C or V into R. Then since the I is the rate of change and flow through the resistor is the same as the rate at which the charge flow out of the capacitor. That can be denoted by I is equal to minus dq by dt. Then the substituting to the simple calculation means you can solve this differential equation. You can make a differential equation dq by dt is minus rc into q. These are the, then we can solve the differential equation. Now I will move on to the Newton's, because he is the man behind the success of calculus. That's why Newton's law of cooling is a differential equation that predicts the cooling of a warm body placed in a cold environment. According to the law, the rate at which the temperature of the body decreases proportionally to the difference of time between the body and the environment. That can be symbolically, we can express dt by T, means that is T with respect to temperature with respect to time, it changes in the environment T minus T. Here T is the temperature of the object, T is the constant temperature of the environment, then K is the constant proportion. Again, this can also be solved by any one of the methods, linear methods. We can solve the differential equation. We get T is equal to Te plus C into e power minus k. You get a cooling of a warm body. This is the equation you are studied in your physics itself. Physics. Now I will move on to one more example. In chemistry, the rate at which the given chemical reaction occurs is often determined by a differential equation. For consider the decomposition of nitrogen dioxide, 2NO2 tends to 2NO plus O2, because this reaction requires two molecules of NO2, and the rate at which the reaction occurs in the proportion to the square of the concentration of NO2. Here, in the rate of change happened, then definitely it is d of NO2 by dt minus k times NO2. Then if you solve that equation, you get NO2 is equal to 1 by kt plus c. This is the decomposition of NO2. This is the one of the example. Although the first order equations are the most common type in chemistry, biology, physics, because physics is engineering, most systems are modeled using the second order equation. This is because of Newton's second law, that is F is equal to ma. You know that McDonald's used this as sales. The variable on and the right hand side of the equation is acceleration, which is the second derivative of the position. Usually force depends on the proposition as well as perhaps velocity. Velocity acceleration happens if you differentiate once velocity, second times you get an acceleration, which means that Newton's second law is really a second order differential equation. For example, for considering a mass hanging from a stretched spring, the force on which such a mass is proportional to the position, we can make it as F is equal to minus ky, where k is a constant. Then you can plugging into a Newton's second law, this become minus ky into m double dash y. This solution is to this differential equation involves sine, cosines, which is why the mass hanging from spring will oscillate up and down. Similar differential equation can be used to model the motion of the pendulum, vibration of the atoms in equivalent bond, and the oscillations of an electric circuit made from a capacitor and an inductor. Now, in these examples, I will conclude with one of the thing: engineering, math plus mathematics combined, you get everything in your life. If engineering minus maths is nothing, and mathematics rules the science and engineering, and science and engineering rules the world. These are the quote I want to conclude my talk. Thank you.
Thank you, sir.
Thank you, ma'am.
That was a wonderful session.
Thank you, ma'am.
Well, students, if you have any question, you can put it in the chat box. Sir, one student has asked about any suggestions on UPSC exam.
Madam, UPSC examination means it is a skill based. You can study in a, because it is also related to mathematics and engineering, means you can structurally study.
That's what he has asked, sir.
He
has asked about how to clear mathematics in UPSC exam.
That is the thing I am telling, because you can see the mathematical equation in a real life situation. Don't think that it is a number matter. Don't see the things in a number level. You can think in a different. I given a hint. What is that? The limit. Limit means we have a limit in our life also. He also make the, first you can make a boundary how to clear. There is a time gap, because it is around 1 year. 1 year time will be there for preparing, but it is a lifetime situation. If you study UPSC, then you can, fundamentals must be thorough with that, then you can apply directly. That's all, man. If you work and fundamentals are clear, it is not a big issue in studying UPSC, or any competitive examination can be cleared easily.
Sir, thank you. I think I'll continue with the vote of thanks. A very good afternoon to all the participants once again. I'm Dr. Asha Patil from the Department of Science and Humanities, BLD Engineering College, Bijapur. First of all, I'd like to thank our beloved principal, Dr. Atul Ayari sir, for his continuous encouragement and support in conducting this webinar. I thank today's speaker, Dr. V. Lokesha sir, for his wonderful session. Sir, thanks for introducing us, the mathematician engineers, and nicely explaining about the formation of differential equations with the real life examples. Sir, with your informative session, you have made us realize the words of John Newman: if people do not believe that mathematics is simple, it is only because they do not realize how complicated life is. On behalf of our principal, HOD, and Faculty of Science and Humanities Department, I would like to once again thank today's speaker, Dr. V. Lokesha sir, who has spent his valuable time with us in spite of his busy schedule. Thank you, sir. Thanks a lot. I heartily thank all the participants, my dear students, for their involvement in this program. Thank you all. I also thank my colleagues of Science and Humanities Department for their heartily support in the conduction of this event. I'd like to wind up with the words of Karin Wu: math is the true superpower humans possess. So learn it, use it, make beautiful things, and solve big problems. Make the world a better place with math. Thank you all. Stay home, stay safe. Thank you, sir.
Thank you, ma'am. Thank you for listening. Thank you for all of our students. Best of luck and stay safe. Thank you, ma'am. Thank you.
Thank you. Dear participants, the feedback link has been shared in the chat box. Please do fill the feedback form and submit it. You will receive the certificate in your registered mail ID. Thank you.